Okay, so I am going to pull this out to the side, my answer key, and we're going to talk about each of the problems. So for number 1, we had a simple question where we would solve a linear equation or an inequality, or in this case, we've just got a simple equation such as 3x minus 7 equals 8. The correct answer was x equals 5, A, and it looks like out of the 18 that turned it in, 16 of you got it right, about 89% of us. That's pretty good. That's pretty good. I'm very happy with that. Now, number 2, we tried an equation with x on both sides. This threw you guys for a loop, I can tell, because we dropped from 89% getting it right to only 50% getting it right. So what this tells me is that we are going to definitely do some practice with equations that have x's on both sides of the equal sign. So we are for sure going to be using these results to kind of determine how long to spend on each of these topics. So this will be one, since about half of you struggled with it, we will definitely spend quite a bit of time going over that. Okay, so let's look at number 3. Number 3 was actually just like number 1. The only thing that was different is instead of an equal sign, we put a greater than sign in here. Numbers are exactly the same. We just got a number times a variable minus a number and then another number. Same setup. So I wouldn't have expected it to be too different. However, let's look at the results. Only 10 people got it right. More than half. That's pretty good. But it looks like this is going to be another topic that we do review a little bit. So if you are in the red area, meaning you did not get those answers correct, I don't want you to be worried. I don't want you to be freaking out that, oh my God, I'm going to be behind. You won't be. It'll be all right. We are going to spend lots of time reviewing this week and making sure that you guys are in a great place to really start jumping into that stuff. Okay, let's look at the last question on page 1. This surprised me, and I wonder, so first of all, solving a system of equations. We've got x plus y equals 10 and 2x minus y equals 5. To solve a system of equations, we want to find the x value and the y value that fits into both of these equations. I was expecting not a lot of people to get this one right because it was a newer topic in Algebra 1, and because, to be honest, before I taught this in Algebra 1, I looked at it and I had to reteach myself before I taught it to you guys. So I assumed that since it was something I didn't know how to do before, it'd be something that y'all didn't know how to do. But you guys did pretty well on that. About 2/3 of you got that correct. So I was really surprised by that. Now, I wonder if so many of you got it right. I wonder if it's because originally maybe you left it blank, and whenever we went over the answer, you filled it in and didn't mark that you got it wrong at first. So maybe when I was looking at your results, it looked like you got it right. So that could have skewed our data, possibility. Either way, looks like it's going to be something that we will go over. So let's move on. Before we go to that next page, though, does anyone have any questions about that first page? The floor is open. You're welcome to ask anything. Yes?
I would say, like, it's just the fourth one for me.
The fourth one?
Yeah,
The system of equations here. Yeah, that one was really, it's tough. Because whenever we're used to just solving for one variable, manipulating two different equations, it's a beast. You know, it's a totally different thing entirely. So we can absolutely spend some time going over that in depth. We're probably going to be skimming through this a little bit, not getting too detailed and involved, but once we've gone over the results, we're going to get really into it and start learning how to do the things we didn't know how to do. So, next page, let's look. Number 5. Now, I was also very surprised by these results because I think I operated under the assumption that slope is something that is taught heavily in Algebra 1. I feel like we work with slope a lot, at least in my classroom last term we worked with slope a lot. So maybe I just had that assumption that, okay, yeah, we're gonna nail this question. I think we got it. I was really surprised by the results. Now, what I think those results might mean, let me show you first. Here's what we got. 61% of people got it right. So that's not terrible, but it's still only about half. What I think that some of this might have been is you look at it, it's been years since you've done it, you do not know where to start, but once we go through and explain it, practice it, I think it's one of those things that's going to click in your brain pretty quickly, or at least it should, and if not, you know, we can always work on it a little more. So that's number 5. We worked with slope and using 2 points to find it, slope of a line. About 11 of you got that right. Let's look at number 6. Half of you got this one right. This was asking if a linear equation is a function. Now, I wasn't expecting, I actually think you guys did better on this question than I was expecting, because in Algebra 1, I never asked you a question like this. I never asked you if an equation was a function. We always looked at a bunch of coordinates to figure that out, or we would look at a line to figure that out. So 50%, I'll take it. I'll take it. We'll go over it some more though. Okay, and number 7 was to look at an equation, y equals mx plus b, and be able to tell me which number was the slope, or your m, so that'd be -3, and which number was the y-intercept, where the line is touching the y-axis, or your b, which was 2. So the answer here was C, and it looks like only 39% of us got that right. So that's going to be something else that we go over. It sounds like, honestly, let's be honest, we are going to do a lot of review. We're going to do a lot of review because I think it would be silly when my results are looking like this and the majority of questions, half or more than half, are not understanding how to do something yet. I would be failing half of you as a teacher if we did not go back and make sure that you all are ready to do harder things. I'm not going to jump ahead and do stuff that you don't have the foundational skills to do. So don't worry, I got you all. We're going to be okay. I'm going to catch you up, get you where you need to be. We will be successful. All right. All right, so let's look at page 3. I threw this stuff on here for fun, just to see if anybody knew how to do it. We didn't even touch this in Algebra 1. So if you got any of these right, that's amazing.
I got all of these wrong.
Well, that is okay. That is okay. I didn't expect anybody to get these right. Again, I just kind of threw them on there, see what would happen. You got 2 of them?
I do have 2.
Which 2?
I got 8 and 11.
8 and 11. Man, look at you. Well, good job.
That's 8, 9, and 11.
Good job.
Thank you, Jesus.
I love it. Okay, so number 8. I'll talk about these a little bit. We have where we are simplifying or kind of combining like terms, multiplying, doing things like this with numbers that have variables with exponents. Okay, so very quick, tiniest mini lesson you've ever heard in your life. We're going to do a long lesson on this later. But whenever you have 2 terms by each other in parentheses, what operation are we doing? Multiplication. Yes, things in parentheses we multiply. So I am multiplying 3x squared times 2x cubed, or to the 3rd power. So my 3 times 2 is what? 6. And exponents are funny. Whenever you multiply exponents, you actually do something different. Anybody know what you do? You add them. You add them.
I was
And
about to say you can't, but
yeah, so you actually add them. We will talk about later why we add them instead of multiplying, but all I would do is take my 2 plus my 3 and put 5. So it's something that's actually very simple to do, especially once you've gotten that explicit instruction where I'm telling you exactly how it works, why it works. We'll get into that later on. But number 8, our answer was D. Let's see how many of you got that right. Woo! Only 4 people. That's all right. We didn't go over that in Algebra 1. Yeah, it would have been 5. So, hey, if you are one of the 4 that got that right, give yourself a pat on the back. That is excellent, okay? I wasn't expecting anybody to know how to do that, so I'm impressed. Very nice, very nice. Okay, let's look at number 9. This one isn't too bad. We just didn't talk about it much at all. Actually, we didn't talk about it. Okay, we didn't talk about it in Algebra 1. Whenever we see a number that is under what we call like a square root, we call this a radical number. That just means that we are trying to find what number do I multiply by itself to get 49. So if I were to go through and try to figure that out, I would see that 7 times 7 is 49. So my answer here is 7. The square root of 49 is 7. The square root of any number is whatever number I multiply by itself to get that number. Again, that's something we'll review in more detail later on. Your answer is C for 9. More of you got that than I thought would. 72% of you got that right. Really?
no, I didn't do it. Never mind.
Oh, that's all right. That's all right. And remember, guys, this isn't for a grade. I just wanted to see what you knew, what you didn't know. This will not affect your points on synergy, okay? Oh, that's okay. That's okay. Okay, let's look at number 10. This is another one I wasn't expecting anybody to get correct. So if you did get it right, that's wonderful. But let's talk about this for just a moment. Again, this will be a brief baby overview. We are going to go in more detail later on. But this is about the basics of factoring. If you don't know what factoring is, that's okay. We're going to learn about it. Basically, what I asked you in number 10 to do is to factor out the greatest common factor from the expression. So factors are just numbers or terms that you can multiply to create a different number or term. So what I did here is I saw that 3x times 2x minus 3, when I distribute that, I'm going to come up with this answer. So the reason that A is our answer is because when I'm looking at this here, I'm trying to think, what can I take out of both numbers? Well, they both have an x, so I'm going to take an x out. So from here, if I take x away from 6x squared, I'm going to have 6x left. If I take x away from minus 9x, I'll have minus 9. So there's my first part. And some of you got this far. Some of you put C as your answer. If you did, you were very close. Now, we can go one step further, though. What number can I take out of both 6 and 9? 3. So if I did 6 divided by 3, I would get 2. So I'm going to take a 3 out, and I would come up with 2x. Man, this is tiny. Let me zoom in for you so you can see that a little better. Okay, so I've got 2x, and then 9 divided by 3 is 3. So we would come up with this as our answer, which is A. Again, if you're lost while I'm explaining this to you, don't worry. We're going to go in way more depth later. This is just like a very fast skimming over, okay? So nobody get worried yet. Nobody get worried yet. So number 10, let's see how many of us got that right. Also 4, 22% of you. 4 people got it right. Not too bad.
What was that answer again?
The answer for number 10 was A. Okay, let's look at 11. So we actually did do something like this in Algebra 1, but just briefly, these were like bonus questions on a quiz we took. So this is a word problem. It says a car rental company charges $20 per day plus an additional 10 cents per mile. If the total cost of renting a car for one day is $35, how many miles did we drive? So here's how we would set that up. If I know that this company is charging $20 per day, that means I'm going to be taking 20 times however many days that they drive, but it says that they only drove it for one day. So I actually don't need to multiply 20 by anything. I know here that my total cost is 35, so why don't I go ahead and set something equal to 35? So I've got this here, 35, that's my total. And to figure out what else I'm going to put for this equation, let's look back at our problem. So 35 is my total. Okay, so I know that they're only going to rent for one day, and it's $20 a day. So I went ahead and wrote 20 right here because I know they're going to be paying $20 for that one day. I know that their total was $35. The question is, how many miles did I drive? So it says that we're going to be charged 10 cents for every mile. So I decided to put 10 cents times something. I don't know how many miles. That's what I want to figure out. So to figure out how to get to that total of 35, I've got 10 cents times, I don't know, some amount of miles, plus that $20 fee is going to equal 35. And I just solved it like an equation. I did minus 20 on both sides. That canceled. 35 minus 20 is 15. And I drop down my 0.10x right here. Divide by 0.10. Divide by 0.10. And when you do that, x goes by itself. You get x equals 150. So B is your answer there. B is your answer. Let's see how many people got that right. Okay, a little over half of you got that right. So not bad, guys. Not bad. A little over half of you. Let's look at the next page. Okay, these we struggled mostly because some of you didn't get a chance to even try them like we were working on the other ones. So these results are going to look very different. And I'm not going to take them into as much consideration as the rest of the results. So let's just walk through what's going on here. Number one, I had you solve an equation for x, and this equation had an x on both sides, which we struggled with previously. The x on both sides, half of you got correct. See that? That was for number 2. So as I might have expected, we got the exact same result here. Half of you got it right. Exact same result. So we would have done this here. I would subtract 3x from both sides to get rid of this 3x. Bring everything down. 5x minus 3x is 2x. Bring down my minus 4. Bring down my equal. Bring down my 12. I'm going really fast. We'll do this much slower later on. So don't freak out, guys. I'm just skimming through. Then we solved it. Okay, so long story short, your answer would have been x equals 8. Okay. Again, we'll go through this in much more detail as we review more. Like I said, you guys got the exact same result for this problem as you did on that original question. Okay. Let's look at the second one here. This was another solving systems of equations for number 2 on the back side. You could have used substitution or elimination. In my example, I used elimination. I saw that I had x and 3x, so to make my x's go away, I just multiplied this equation by negative 3, so that I would come up with negative 3x and 3x, so they would cancel. Negative 3 times negative 2y gives me positive 6y. Negative 3 times 4 gives me negative 12. So since those are gone, I just add 6y plus y makes 7y. Negative 12 plus 5 makes negative 7. And I just went through and solved for y, got negative 1, went through, plugged it in, solved for x, got 2. That would be my answer. I'm going really fast, guys. Okay, again, we're going to review this after we go over these results. So for number 2, on the back, which I put as 13 on here, only one person got that right. So if you were the one person, good job. But yeah, we're going to review that big time. One person got it right. So that just tells me that we need to work on it, and that's okay. No big deal at all. No big deal. Okay. Number 3 on the back. How do you guys think that you're going to expect the results to be for this one?
Horrible.
Horrible? Anybody think it's going to be good?
It's gonna be okay, maybe so.
Going to be okay. Give me a percent. What do you think the percent is that got it correct?
35.
About 35%?
40.
33? Any other guesses?
Mine's marked as correct, but I only have half of it done.
Oh, that's all right. That's all right. Okay, let's check. Da, da, da. Only 5 people got it right. We struggled. That's okay. That's okay. A lot of this was because some people didn't get to attempt it. We ran out of time, and so it was blank, which caused a lot of the incorrect answers. Some attempted it incorrectly, and that's okay. It'll just be something that we practice. Again, we'll practice a lot of things today. And last but not least, factoring quadratic expressions. Oh yeah. We didn't even get close to touching this in Algebra 1. I threw this on there just to see if even one person could do it. How do you guys think the results on this went? Bad? Bad? Let's see. Nobody! Everybody got it wrong. And that's okay. That just tells me that we are going to absolutely spend probably an entire 3-hour class on factoring. So here's what I'm thinking about all of these results. I'll zoom out a little. I'm going to set this up almost kind of like a ratio or a proportion as a guide to tell me how much time do we need to spend on each of these topics. So if 100% of us got this wrong, or 0% got it right, I'm going to say that this length here is going to tell me we're going to spend at least a whole class, maybe 2, on this topic. So I'm thinking if I were to try to come up with like a mathematical plan to getting us where we need to be, what do you guys think about the idea of taking this length here, I'm going to do this, and saying that this length, let's say, equals 3 hours of practice. So, hypothetically, I could take this length and line it up with my other ones to see about how long we need to work on the other ones. What do you guys think of that?
Sounds good.
Okay. Do we have any other, let me ask you this. Looking at these results, now that you've seen the assessment, you've seen the topics that I wanted to kind of see how you're doing on, does anybody have any kind of ideas or, I kind of want to open the floor to you guys. Any suggestions, any really big worries for things that they think we should definitely be spending a very large section of time reviewing? The graphs. Okay, let's make a list because I want to hear your feedback and I want to make sure that I'm giving you what you need. So, let me zoom out a little. Okay, So we said, first thing I'm going to write is factoring, because we are definitely going to spend a ton of time talking about factoring. Okay, so graphing. I'm just going to write linear equations, because what a linear equation is it's that like y equals mx plus b. So that's going to include the slope, that's going to include graphing, that's going to include finding coordinates, that's going to be kind of the whole overview of all of those topics that some of you guys were struggling with. So I'm going to write linear equations, because Algebra 2 is very heavy on equations, so we need to be able to comfortably and confidently mess with these before moving on. Linear equations and graphing. Okay, so we know we want to do factoring. We know we want to go over linear equations, graphing, slope, coordinates, all those things. Any other thoughts that we're having about this stuff?
Quadratic expressions.
Quadratic expressions? Yes, that'll be part of factoring for sure. And what'd you say, Matt?
I don't remember none of the terms in math. Like, I haven't been in school for 14 years, so I didn't have a refresher.
Yeah,
So
okay.
most of us lack because it's been so long. We didn't have a refresher.
Right.
Just into Algebra 2.
You got it.
And it's been our whole
So,
lifetime, so.
and I appreciate you bringing that up, because, you
So
know,
the
that's...
terms and stuff that you use in math is kind of, like, I got some of the questions right, but the ones that I didn't, I just didn't even attempt. I don't know exactly what it means, but I just guessing.
Well, honestly, as a teacher, it's a great reminder that, you know, whenever I'm like in my math zone, because it's what I do. And I forget that for those of you who are a little out of the loop, you know, it's been a while since you've done this. It's like learning a new language.
Yeah.
It really is. There's a lot of words that when you hear them, you might be thinking,
Yeah.
like, what? What even is that? What does that mean? And, you know, I understand that if you're feeling like you have to ask that question every 5 minutes, you're probably not going to ask every 5 minutes. And then I'm not going to know that you don't know. So I appreciate you saying that in general, because that helps me remember and clue me in on, you know, we probably do need to go over some of that math language and make sure that we are all caught up and you know what I'm saying when I say it. So thank you, thank you. So I'm going to say refresher on math general terms. And I'll make sure to just be more specific whenever I do say a word that's mathy, you know. And I also want to encourage you guys, if at any point, even if it is every 5 minutes, if it's every 30 seconds, and I'm saying words that you don't understand, you can tell me, okay? I won't be frustrated. I won't be upset with you. You know, as long as you're being honest and you are genuinely trying to learn and understand, you're like, hey, what does that mean? What is this? And you're not just trying to mess with me. Don't do that. I'm happy to explain, really. I really am. Okay, and what else are we thinking, guys? So we got factoring quadratics, we've got linear equations, graphing, slope, coordinates, blah, 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 general math terms.
I like a refresher on
Page 3. Let's see what was page 3. Okay, so this, page 3, wouldn't even necessarily be a refresher. This is going to be a new lesson when we go over it, because we have not ever done this in Algebra 1. So if you just got out of Algebra 1 and you're thinking like, why don't I know this? Because I didn't teach you. So don't worry, I will teach this to you. So let me put that on here. We're going to definitely talk about, we got factoring on there. That was part of page 3. The other one is exponents. Oops. And radicals. Maybe even a few word problems. Now, I personally hate word problems. Never have liked them. Like, I understand that in some contexts, word problems are useful for putting an equation kind of into perspective so you can see why we do things the way that we do them. However, I think a lot of word problems that exist are just not super realistic. I feel like a lot of math books or worksheets that exist out there, when they use word problems, I wish I could come up with an example.
At the beginning of the day, the store had 300 soaps. And
Right.
This guy came in and bought 3/4 of them. Why
Right.
do we need 250 soaps, dude?
Right. Well, and also in the context of the real world, when are you gonna need to know that? You know, I understand maybe you're taking inventory or something, but like in the way that the world works, a lot of things are very automated now. You know, we have little scanners to count product. There are certain things that I think we are just not going to use, and so I don't know. I don't want to spend time teaching stuff that is irrelevant to you. However, there are some things that are just irrelevant to you and I have to teach you because they're standards. So in those cases, I'm going to do the best I can to make it make sense. But, my goal is not for you all to be mathematicians. My goal is for y'all to get your diplomas, okay? So we're going to do our best, but the deal is if you guys show up here, if you guys are doing the work, putting in effort, you will be successful. You're going to pass this class. We will get through it. It might feel like a struggle at first, but we will do it, okay? As long as you're communicating with me, you're telling me what you need, we can do this, and I will try my very best to provide what it is that you need. Okay, any other ideas for our plan moving forward? Any other suggestions, thoughts, worries, things I should know?
I suck at algebra 2.
You suck at algebra 2. Guess what? We're going to change that, girl. Right now, I think all of us probably feel that way, and that is okay. I'll tell you what, whenever I first started planning for teaching Algebra 2, I had my own little mental breakdown because I was thinking myself like, oh my God, like this is intense. This stuff is kind of crazy. So, I'm not ever going to give you stuff that I don't feel good about giving you. You know what I mean? Like I'm going to make sure that I can understand it in a way that's going to help you understand it. And I'm gonna be holding your hand through this. I'm gonna guide y'all through. Oh man, hang on guys. Let me pause this and see what's going on. Come on. Today, we are going to work on the basics of Algebra 1. We're going to make sure that you guys have that foundation so that we can move forward. So I would like you to start a page of notes. And we're going to start with our basic algebraic operations, which is combining like terms. And I'm going to tell you what every word on this page means. Okay, so I'm going to give you guys a minute to get paper out, get settled, and we're going to go through all of these very slowly together. If you do not have paper or you need a notebook, you need something to write on right with, this shelf up at the front of the room, there's lots of empty notebooks up here for you guys to keep if you like. There's also lots of colors up here for you to write notes with. If you would rather have loose leaf paper, I've got some up here. There's graphing paper. There is just basic lined paper. Whatever you need, feel free to get up and help yourself. And I'll pause this while I'm waiting for you guys to get ready.
Network not available.
What?
Yeah, mine
Oh, are you kidding me? Well, if we have to, we'll do it the old-fashioned way. I'll write on the board. And that's fine with me. But that's going to suck for the people that aren't here today.
Oh, that's gonna suck for real. Can't go back and sit.
Failed to connect.
I think we're gonna do 3 times 5.
Okay, it looks like it's going to reconnect.
Sorry, reconnect now.
Yeah, it is. Let me reopen this. Okay, so whenever we are trying to combine like terms, guys, we are not solving for x. We're not doing anything other than what our symbols here are telling us. We're just adding, and then we're subtracting. So you were actually correct when you said we're adding 3 plus 5. We are adding our x's together. We're going to try to see how many x's we have total. If I see 3x, that means that I have 3 x's. If I'm adding 5 more x's, if I start with 3 x's, then I add 5, how many x's will I have then? 8 x's. So 3 plus 5 is 8. I'm going to cross off 3x and 5x, and I'm going to write 8x so I can keep track of my work. Am I done? No. What else do I need to do? Yeah, we still have minus 2x. Pay attention to the signs. We don't want to add 2x. It's minus 2x. So I'm going to bring that down here. Now my problem is that I have 8 x's and I want to take away 2 x's. How many x's will I have left? 6x. 6 x's. That's your answer. Not so bad, guys. Not so bad. Not so bad. Do we have any questions about that process of combining like terms? Okay. Let's move on to the next one then. Now we've got something slightly more complicated. We have terms that include variables and exponents. And then we've got terms without exponents. So first thing we need to do is decide which of these that are written in this like equation here or expression here, which of these are like terms? Which of them can I even combine?
So you can do the 4x, the second power minus 2x.
Yes.
And then do the same for the other two.
Yes, yes. So I'm going to repeat what she said in case you couldn't hear it. What Cedra just said is that we have, I'm going to start with this one here. We've got 4x squared. So I'm going to underline this. And now I'm going to look through the rest of my terms and see if I have any more with x squared.
2x.
So yeah, not 6x, and then I've got minus 2x squared. So pay attention to the sign right directly beside it, in front of it. I've got 4x squared, and I've got a minus 2x squared. So I know that these are going to go together. I'm going to draw a little line to show that they're connected. Now here's where I would switch colors if you are doing color-coded notes. I always encourage color coding because it is going to help you visualize. So now I'm going to take, I don't know, orange. Do I have any more x squareds? No, I don't. So I'm going to move on to my next value. I've got plus 6x or positive 6x. Where else do I have an x?
3x.
Yeah, I've got 3x. So those two terms are going to be combined as well. So let's think about this. If I'm putting together 4x squared and minus 2x squared, I'm really just doing 4 minus 2. And then I'm going to write my variable and my exponent on it. Where people get a little confused on these is they see the exponent and they start doing too much work, more than they need to do. They see, oh, well, 4 squared is like 16, and negative 2 squared is 4. 16 plus 4, that's 20. Too many steps. You're just looking at the numbers in front of the variables. We're not solving for x. We're not trying to figure that out. We just want to look at the numbers, the constants. So if I have 4x squared, I got 4 of these x squareds, and I take away 2 of my x squareds, how many x squareds am I going to have left? 2, because 4 minus 2 is 2. So down here I've got 2x squared.
So it's just
subtracted 4x from negative 2x?
Yes, I just took 4x squared minus 2x squared. I'll write that out down here so everybody can see what I did. 4x squared minus 2x squared. And that's the first part. You guys see how I got that? I just brought those down, subtracted, and here's the first part of my answer. Now, are we done? No, we still need to combine our x terms. So I've got a positive 6x. I got a positive 3x or plus 3x. How many x's am I going to have all together when I combine? 9. 6 plus 3 is 9. So, because we've got a positive 9 here, I'm going to bring this down. Plus 6x plus 3x is 9x plus 9x. And guys, x squared and x are not like terms, so we cannot combine any further. This is as far as we can go. I'm going to rewrite it all in one color here just so that it's consistent. My answer is 2x squared plus 9x. That's as far as we can go. Sometimes we're going to have to get comfortable. Algebra 2 is kind of a very abstract sort of math subject where we do need to be comfortable with having answers that still have addition and subtraction in them. This is our answer. We're not solving for x. We're just seeing how we can combine all these terms to make it as simple as we can. Yes?
Okay, so that's what I got.
Mhm.
I know that there's going to be like another equation that does involve.
Star, you're here.
I'm here, guys.
Yay.
Yay. Sorry,
You're okay. Thank
I'm
you.
sorry.
Stop. You're so sweet. From Star. I know. She knows I love her beer. Cedra, I'm sorry. Continue. I'm listening.
So like I know like to the second power, there's gonna be like another equation in algebra that I went through before.
Uh-huh.
And like sometimes you add them, sometimes you don't. Like sometimes it'll have like the main number and
Okay.
you like multiply those, but sometimes you'll just add those. Like the power. Like I've done that before. With a different type of.
I'm trying to think of,
I just don't know like when to do that. That's why.
do you by chance have an example of that type of problem maybe?
Okay, like I guess maybe like 7x squared.
Uh-huh.
And then times 7x squared again. Something like that.
Like this?
Yeah, something like that, yeah.
Okay, and so what are you saying is happening here?
A long time ago when I was in school, they taught us that you pretty much, when it comes to the bigger number, or like the main number, you just multiply those, but then you'll just add the number.
Yes, okay, so you're talking about like multiplication rules for whole numbers versus multiplication rules for exponents.
Okay, because like I was like
Yes.
sometimes to know, because it's like, why is it we don't do that with one thing, but we'll do it with
Yes,
another?
so guess what? The whole next page, we're doing that.
Oh, wow.
And we're going to talk all about it today. So you are absolutely, you're like reading my mind, girl. We're going to talk about that today. Yeah, so if anybody's curious about what that conversation is that you just missed, Cedra was asking about the difference between when we're multiplying numbers with exponents attached, why are the multiplication rules different? Like when I do 7 times 7, I just type that in my calculator and I'm going to get 49. But whenever I'm doing exponents, now this is a bad example because 2 plus 2 is the same thing as 2 times 2. But whenever I multiply exponents, I'm actually just adding the numbers instead of multiplying them. We are going to talk all about that on the next page of my notes. So, sneak peek, if you were just curious. You don't need to worry about that just yet. Right now, we're starting at square one. We're just talking about how to add and subtract terms. So, great question though. We will get to it. All right, any questions on this second problem that we just did? Where we got 2x squared plus 9x as our answer?
I think I got it, but
You think you got it? What do you think is throwing you off or confusing you the most about this process here?
square part.
The squared?
Squaring.
Okay, so how about this? Let's replace this and not do x squared because that looks scary. Let's do instead, I'm going to rewrite the problem, but as like a picture. 4 green circles plus, whoops, sorry guys, knocked my plan off of my desk. 6 orange circles.
Wait, what are we doing?
You'll see. You'll see. Minus 2. I'm gonna show you a different way to think about this that might help make it simpler in your brain.
Okay.
Plus 3 orange.
Are we not really worried about this, the square number? Is that the right, like, is it like supposed
Yeah.
to be really invisible?
Yeah, kind of. So basically, if you are looking at this problem and all these x's and the little 2's, the square numbers, if this is like freaking you out, let's totally simplify the problem, okay? Let's say instead of writing x squared, we are going to write green circle. So 4x squared is just 4 green circles, okay? Instead of minus 2x squared, we're going to do minus 2 green circles, okay? And then same thing, instead of 6x, I'm going to put 6 orange circles. Instead of plus 3x, I'm going to do plus 3 orange circles. All we're trying to do here is figure out how many orange circles and how many green circles am I going to have. Now, can I combine those orange and green circles? Can I say that I have 10 circles here? No, we keep them separate because they're not like terms. Just like up here, I cannot do 4x squared plus 6x because I don't know what x is. We can only combine my x squareds, my green circles, and my x's, or my orange circles. So let's work out this exact same problem but without all the x's and squareds. So if I got 4 green plus 6 orange minus 2 green plus 3 orange, what's really happening here? So I'm just looking to combine the colors that go together. I have 4 green minus 2 green. Okay, 4 minus 2 is what? 2 green circles. Okay, just like we got 2x squared. Then I have 6 orange plus 3 orange. 6 plus 3 is? 9. So plus 9 orange circles. Same thing as plus 9x. I'm just showing it differently. Does that make a teeny bit more sense? Just kind of visualizing it without all the crazy letters and numbers. I know sometimes that just really throws people off because especially I hate that they teach the multiplication symbol as an X because then people look at this and think, okay, 4 times squared plus, like it's so confusing for no reason. It's so confusing for no reason. I will probably never write multiplication as an X in the context of a problem. When I'm multiplying, I'm usually going to write it like this. I'm going to put them in parentheses by each other. Or, yeah, I mean, honestly, that's probably what I'm always going to do. I'm going to put it in parentheses.
My teacher back in middle school would put a dot.
Yeah, or a dot. That's another way to do it, absolutely. Okay. Any questions, guys, about the second one before we move on?
No, thank you.
Good, yeah.
Third one.
All right, let's do the third one. Okay, we're going to use some colors again. I'm going to pull out a third color because we've got a third term here.
I was like, where's the term?
Yeah, let's look. Okay. I've got 10x squared minus 3x minus 4x squared plus 7 plus 2x equals, oh my goodness. Okay, I know, this is a lot. Let's go step by step. Take a breath, one thing at a time. We're going to start from left to right. We have 10 of these x squareds, okay? 10 of these x squareds. Where else do I see x squared? Yes, I've got a minus 4x squared. Do I have any other x squareds? No. So I know here that I'm done looking at x squareds. If you want, you could take this time to cross them off and rewrite them beside each other so that it is kind of together. They're grouped. So I'll do that. Let's do 10x squared minus 4x squared. Yeah, 10 minus 4 is 6. So I have 6x squared right here. So now let's look at the next variable. And I want to kind of slow down here. I want to wait. Does anybody need more time to get this first part written down? Okay, everybody ready to move on to the next part? Okay, yeah, take your time. You're good. Okay, so now we're going to keep going left to right. What's my next term?
3x.
Not just 3x. Yeah, negative 3x. There's a minus sign in front of it. This is a negative number. Negative 3x. I'm looking for any other terms that have x attached. 2x. Good. So I'm going to be putting those together. I've got negative 3x plus 2x. And yeah, okay, that's going to give me negative 1x. Negative 3 plus 2 is negative 1. If you are struggling with adding negative numbers and things, use your calculator, okay? Does anybody not know how to type negative numbers on a calculator? We can go through it if we need to.
Is the negative sign in parentheses, right?
Yes. So here, let's just do this together real fast. If I want to do negative 3 plus 2, I'm going to type negative. Oh, is it off? No, it's on. Let me zoom out a little so you can see. And okay, so I hit this button down here. Bottom right, it's the minus in parentheses. That's negative 3 plus 2 equals negative 1. So that means we've got negative 1x, guys. So I'm going to write negative 1x. There we go.
You can't do anything with the 7.
Yeah, we still have something left. Exactly. And Cedra just said we can't do anything with that 7. So guys, I did my x squareds. I did my x's. And what's left, everyone?
7.
Yeah, we have 7 left. Plus 7. Is there any variable attached to that?
No.
No. So can we combine the 7 with either of these? No. So we need to make it its own category. I'm going to drop it down and I'm just going to put plus 7. And guys, we found all 3 of these. We just need to write them together as one final expression. So to do that, I am running out of room. I'm going to tilt my paper just a little bit. I'm going to write, oh, that's going to make you guys dizzy. 6x squared minus 1x, or you could just write minus x. We don't ever have to put the 1 in front of an x, because if I have minus x, that means I'm taking away an x. 1 times x means I got 1x. So I can either write minus 1x or minus x. Okay, I'm going to put minus x if you guys are okay with that. Plus 7. And that is your answer. So we circle it. Always circle your answers because this is a whole lot of numbers and letters to search through to find an answer. Always circle your answer. Okay. How's that feel, you guys? A little better?
Yeah.
Good. Good. Any questions about any of that? Okay.
The more we do it.
Good, good. That's my goal. I think the more and more we do these things, the better we're going to feel. Okay, guys, it is 11:52. We've got like 3 minutes till lunch officially starts. I'm going to let you go a little bit early. Please come back after lunch. We will be back in this room at 12:35. 12:35. Okay. So here we are. We are now going to talk about something called the distributive property. The distributive property. Has anyone heard of, or is anyone familiar with that word distribution? Yeah, few of us. If you just took Algebra 1, you should be very familiar with it. Yes.
You got somebody heard that was not in here at all, so she was completely lost.
Oh, who is this? Oh, hello. Welcome, welcome. Here, let me pause this, and I'm going to get you caught up for a second. All right, we're back. Let's talk about the distributive property. So if you are familiar with distribution, guys, can anybody tell me what operation is happening when we are using distribution? Multiplication. So just like we talked about earlier, whenever we have a number and something else, whether it be terms, numbers, other things, variables, in parentheses beside each other like this, that means that we are multiplying them, okay? So whenever we have two terms inside parentheses and we are trying to multiply by this 5 here, yeah, that is really delayed, sorry guys. What we're doing is we're taking 5 times x and 5 times 3. So let's write that out. I'm going to write the process out. What's happening here is I'm taking 5 times x and so plus 5 times 3. Here, I'll do this. All right. So real quick, if I have an x and I make there be 5 of them, you know, if I do 5 times x, what is that going to give me? 5x. 5x. Absolutely. 5 times x is 5x. And then I've got a plus here. So I'm going to bring that over next to my 5x. And let's do the second part. What's 5 times 3? 15. So I'm going to write 15. Now I have 5x plus 15. So looking back to what we just did with combining like terms, are these like terms? No. So we cannot combine them. We cannot go any further. That's our answer. That's it. So let's practice with the next one. Now I have 2 times the quantity 3x plus 4. What am I doing here? Yeah, I'm doing 2 times 3x, and I'm really going to encourage you guys to draw these arrows. It might seem silly, but it can help you visualize what exactly is happening here. When we distribute, we're multiplying this outer term by each of the terms inside. So 2 times 3x, what is that? 6x, very good. And now I'm doing 2 times 4. Good, and what's 2 times 4? 8. So I'm going to put plus 8. Now I have 6x plus 8. Can I go any further? No. Nope, that's my answer. Very good. Okay, I want you guys to try to do the next one on your own. X times the quantity of 2 plus 5. Okay, I want you to try that one on your own. I'm going to pause this, give you about 30 seconds. Okay, who feels confident and would like to walk me through this?
I can try.
Oh, I see a couple people. Oh my goodness, I hate picking. I did see Jeremiah's hand first. I heard your voice first, but Jeremiah, I saw your hand first, so I'm gonna honor that. Jeremiah, how do I do this?
So let's multiply that x to both 2 and 5.
Okay, awesome. So to show that, I'll do this. X times 2 and x times 5. So tell me more.
Okay, since now we have 2x plus 5x, we can add both like terms together.
Yeah. Ooh, guys, look at this. We have 2x because x times 2 is 2x. Then we have 5x because x times 5 is 5x. And unlike the other ones that we just did, these are like terms. So we can go a step further. What is 2x plus 5x? 7x. Good. So 7x is our answer. All right.
I got 7 by itself because I ended up multiplying the numbers by x, and I got just 2 and 5. That's what I did.
Okay, so you did.
Because I put x's separately.
Yeah, I basically took the x out and just did the base of math.
Okay, so did you? Okay. I see now. Did you just do 2 plus 5? So then it was x times 7, and then you got 7x?
Yeah.
You could do that too. You could do that too. Absolutely. So there's 2 ways to solve this. Let's write out that second way in case anyone is confused. So whenever we have x times 2 plus 5, I'm just rewriting the problem, okay? So let's draw a little line here. This is the other way you could do it. In this case, 2 plus 5, 2 and 5 don't have any variables attached to them, so they are like terms, and we could go ahead and combine them first. They're in parentheses. So, what is 2 plus 5? 7. And then I know that I'm doing 7 times x, which is 7x. That's another way to get to that answer. Absolutely. Yeah, no, thank you guys for pointing that out. That's a really smart way to do it. Both ways are perfectly valid. Just make sure that we remember that, in this case, this is special. 2 and 5 are like terms, so we can combine them. However, in these other examples, we could not add x plus 3 first. We don't know what x is, and these are not like terms. Same with the second one. We don't know what x is, so I cannot combine 3x and 4. 2 and 5, yeah, you can combine those. Awesome. Any questions about that? Okay, let's try the next one. Here's where we have to really be careful with our signs. By signs, I mean positive numbers and negative numbers. We call those signs. Okay? Yeah, so, okay, Star, here, you tell me what's going on here.
Nothing. I forgot my minus sign again.
Okay. Yes, Cedra.
Okay, so like pretty much what you're going to do is you're going to do your -3, times your x.
Okay, so you're doing -3 times x. Got it. And what's that going to give us?
Just -3x.
-3x. Great.
And then lastly, you're going to do your -3 times your 2.
Yeah, -3 times 2, and that gives me? -6. Okay, so guys, whenever we do -3 times 2, remember a negative number times a positive number, that's going to give us a negative number. So we got -6. But where did that plus sign go? Does anybody know what happened to it?
It turned into a minus sign.
Yes, it turned into a minus sign, guys. Whenever we put that -3 onto that 2, it just turned it negative. We're actually taking 6 away. I could write -3x plus -6. I'm going to draw a line to separate. You could do that. However, we don't need that extra plus anymore. When you add a negative number, it's the same thing as subtracting. So if I had, let me get a separate sheet and show you something real quick. This is a concept that a lot of my students have struggled with in the past, so I'm always happy to re-explain it. So if I have, for example, 10 minus 2, what's that going to be? 8. Very good. What if I do 10 plus negative 2? What's that going to give me? If I have $10 and the bank adds a negative $2 charge, meaning they're like charging me $2, what am I going to get left? How much money I got left? $8. 8. Guys, I got the same answer here. 10 minus 2 is the same thing as 10 plus negative 2. Anytime you have a problem where you're adding a negative, we want to make it as simple as possible by not having two of these signs beside each other. We want to change that to just 10 minus 2 because it's the same thing, okay? Is anybody confused about this at all? We can run through another one if we need to. You get it? Okay. Okay. Any questions about that? Can we move on? Okay. All right, so this problem here, negative 3 times the quantity of x plus 2, we got negative 3x minus 6. Because we got plus negative 6. That's the same thing as minus 6. Here's our answer. All right. Everybody okay with that answer? Okay. Let's do the last one now. In our last problem, we have negative 5 times the quantity here of negative 2x plus 7. What do we do first? Yes, negative 5 times negative 2x. What happens when we multiply two negative numbers? Yes, those negatives cancel out. It becomes a positive. Yes. Yes, we're just taking notes on paper. And if you need a notebook paper or a notebook in general, up there at the front on that shelf, the bottom shelf there's a bunch of notebooks. You're welcome to take one for yourself. If you prefer loose leaf paper, then right over here, right beside my desk, there's some paper under these turn-in trays. So up to you, whichever you prefer. All right, so if we are multiplying two negatives, we get a positive, okay? Everybody okay with that? Yeah. Great. So what is negative 5 times negative 2x? 10. Yeah, 10 what? 10x. Very good. We don't want to lose our variable there. We're going to get positive 10x when we multiply those. How about the next part? We've got negative 5 times 7. Negative 35. Good. Different signs give us a negative answer. So I'm going to show this whole process, what we did earlier. I've got a plus, and then I've got negative 35. How do we simplify this answer? What should I get rid of? The plus sign. We don't need that. That's just extra information. Our answer is 10x minus 35. Great. What? Are we confused about any of this?
You did your big one, boo.
All right, I'll take it as a compliment. Well, thank you. So, any questions? We getting it? Good. Yay, that makes me so happy. Okay. Yes, ask.
I have a question. Okay. No, I don't have a question. I see it. No, I don't have a question.
What were you going to ask,
I
though?
was going to ask the negative, okay, with the negatives, that's what it comes out to, negative 5 times negative 2.
Uh-huh.
Came back, I was looking at it as being a negative, but it's not. I got it.
You got it. You got it. Okay, good. Awesome. Okay, guys. How do we feel about that? Feel okay? Good. Okay. Can we move on to the exponent multiplication?
Yes.
Woohoo! I heard a no.
If you ask a
question.
Star.
Yep.
All right, guys. So, let me show you the exponent multiplication rule here. I wrote this out, so if you want to keep it in your notes, absolutely you can. Maybe highlight it, keep a hold of it. What I gave you here is we've got x to the a power times x to the b power. This might not make sense until we put numbers in those spots, okay? Whenever you have exponents, to multiply them, are actually just adding them together. Our answer is going to be that first number plus that second number. And before we do these problems, I actually would really like to run through an example with real numbers, because Algebra 2 has a very bad habit of being ridiculously abstract. And by abstract, I just mean very tough to grasp, because it's say it again?
Vague.
Yeah, it's kind of vague. It's kind of imaginative. Like, it's not tangible. So I'm going to try my best to make it tangible. I want to give you something to grab onto. Let's start with something simple like, let's do 2 to the third power times 2 to the fifth power. Okay. So, first of all, what does just 2 to the third power, what does that mean? What are we really doing? Yes, 2 times 2 times 2. So I'm going to write that out. And here I am going to put x's. So this 2 to the third power really means 2 times 2 times 2. Whatever my base number is, I'm multiplying it by itself as many times as the exponent, the little number, as many times as it tells me to. So 2 to the third power, I'm going to multiply 2 by itself 3 times. That's what this means. So I'm going to put that in parentheses so I know that that's what this is. Now, how about 2 to the fifth power? How many times am I multiplying 2 by itself? 5. So I'm going to write 2 times 2. Here, I'm going to put a times there. Times 2 times 2 times 2. Okay. So, at first glance, when you're multiplying these, you might think, all right, that's just going to be 2 to the 15th power, because 3 times 5 is 15, right? I'm going to show you why that is not right. The reason we add the exponents when we're multiplying instead of multiplying the numbers is because what we can see here is we've got 2 times 2 times 2. That's what this is. We're multiplying that by 2 to the fifth, which is 2 times 2 times 2 times 2 times 2. So if I were to just knock the parentheses off of there, let's rewrite this. I've got 2 times 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 2. Finally, let's count these. Yeah, I heard somebody say it. Did you say that, Mac? There's 8 of these 2's here. So if I wanted to rewrite this, 1, 2, 3, 4, 5, 6, 7, 8, I would say 2 to the 8th power, because 2 to the 8th power tells me multiply 2 by itself 8 times. That's what I'm doing here. I'm multiplying 2 by itself 8 times. When we break up this problem and we're multiplying our powers, we're really just adding them. I'm just saying, how many times am I multiplying 2 here? How many times am I multiplying 2 now here in the second one? 3 times and 5 times. So if I want to multiply both of these, putting that multiplication symbol in between them, really what's happening here is I'm just making myself multiply 2 8 times now. Not 15. That would give me a much bigger answer. So 2 to the 3rd power times 2 to the 5th power is 2 to the 8th power. And 3 plus 5 equals 8. You guys see that? 3 plus 5 is 8. And that rule is going to apply every single time. Yes? Oh, I thought you were. My bad. My bad. Okay. So there is kind of the run through the concept. Let's apply that here. Now, another rule to keep in mind, anytime we have a number without an exponent, we can assume that that exponent is an invisible 1. Okay? Is everybody okay with that? Is anybody confused by that? By why we're going to put 1 as our invisible exponent? If you are, it's okay. I'm happy to explain.
X by itself just equals 1.
Yeah, because anything to the 1st power, remember, that number tells you how many times do you multiply it by itself. 1, so it would just stay x, okay? So, if I did x to the 1st power times x to the 1st power, what would my answer be? X to the 2nd power. I'm just going to add 1 plus 1. So if I wanted to write my workout, I could say x to the 1 plus 1. You don't have to do this step. I just want to show you. And my answer is x to the 2nd power, or x squared. Everybody see that? Awesome. How about the second one? I've got, yeah. I got a 1 here. I got a 2 here. So I'm just going to make this x to the 1 plus 2, which is x to the 3rd power. Beautiful. How about the next one? Yeah, 2 plus 3 is 5. X to the 5th. Great. How about the next one? X to the 9th. 4 plus 5 is 9. So x to the 9th. Okay. So these first couple of problems are where we're just looking at the exponents. It gets a teeny bit trickier when we start adding numbers onto those variables with exponents. So let's look at those together too. Before we move on to that, does anybody have questions about what we just did?
Can you hold it for a second?
Yes, absolutely. I'll put it like that. Yeah, I forgot, guys. I have these already written out on my paper and you don't, so it is going to take you a little longer than me to write. So you can absolutely tell me if I'm going too fast ever. I don't want to get too far ahead of you. Here, I'll pause this. Yeah, guys, I'm hearing some great answers. So, whenever we have what we call a coefficient or a constant, like a number that's attached to a variable, we're going to multiply it just like normal. 2x times x. Basically, there's an invisible 1 here in front of the x and in the exponent area. 2 times 1 is 2. So I got 2 here. And now x times x is what? X to the 2nd power, or squared. And we want to make sure we're using the correct language here in math. Whenever we have an exponent, we always say to the something power. So to the 1st power, to the 2nd power, to the 3rd power. Yes?
Okay, so like I accidentally put like a 2x1.
Mm-hmm.
I put like just the invisible 1. So pretty much whatever the constant is, that's what you put. So like for the last one, it would just be like 3x to the third power.
So 3x, now remember the 3 doesn't change our power. So,
Oh, it'll just automatically be a 2 then?
yeah.
Oh.
Unless there was a different number on your x's. So if anybody wants to know what Cedra just asked, basically what I was explaining to her is that whenever you are multiplying here, we're only changing the exponent according to whatever is already attached as the exponent on these variables here. 1 plus 1 is 2. That's why we have x to the second power. And here we have a constant 2. That's going to stay the same because we're not multiplying it by another number. That's a constant. Okay? Is anybody confused by that concept?
Now we add a 1 to the x.
Yes, exactly. Perfect. Okay. We ready for the next one? That's our answer. Yeah, it's the exact same thing, guys. 3x times x. 3x to the second power. Perfect. You can also, for the second power, you can also say squared. Either one is fine. You can say 3x to the second power or 3x squared. All right. Any questions on that one? Okay, let's move on to this one here. I've got 4x squared times x. What are we doing here? We've got a 4 as our constant here. Do we have any other constant we're multiplying by? Yeah, there's an invisible 1 in front of this x, but 4 times 1 is just 4. Okay, so we've got 4 here. Now we can look at our variables and our exponents. X to the second power, or x squared, and then x to the invisible 1. 2 plus 1 is 3. 4x to the third power. Does that make sense, you guys? So all we do is, it's kind of like when we're distributing. Like I'm doing 4 times 1, and I'm doing x squared times x to the first power. And so 4 times 1 is 4. X squared, or x to the second power, times x to the first power. 2 plus 1 is 3. X to the third. Make sense to everybody? If it doesn't, you can tell me.
I'm anxious about the last 2.
Yeah.
That's okay. Are we ready to try the last 2?
Yes, please.
Okay, let's do it.
4x.
Say it again. Who said that?
The second to last one for x is that
I don't know yet off the top of my head. We're going to find out though.
Okay, that's what I got.
All right, so let's circle this answer because that one's done. That's our answer. Always circle your answer. Pretty please. Okay, so we need to think back to the distributive property for this one. Whenever we are multiplying something by another thing in parentheses and there's like a plus happening in there or a minus, we need to multiply by each of the terms, guys. So here's what's happening. I'm taking 2x times x and 2x times 2. Okay? So let's start with this first problem, and I'm going to write it out underneath. What is 2x times x? 2x squared. Yes, whoever said it, that's correct. 2x squared. Thank you, Kelly. 2x squared. Is anybody confused about why this is 2x squared?
Yeah.
Let's talk about it. Okay, I'm going to pull a sticky note out and write it out to the side here. So, it's the exact same problem as we did right here. 2x times x. Remember, 2x times x. If I take x times x, remember there's the invisible 1 there. What's 1 plus 1? 2. So 2x is just going to give me a 2 there. X times x, or x to the first power times x to the first power, is x to the second power, x squared. You guys see how we got that? Okay, so the first part of our problem, we did 2x times x. That's going to give us 2x to the second power, or 2x squared. All right? Now let's write our plus sign. Now we're going to do the second multiplication problem. What is 2x times 2?
4x.
It's just 4x. And can we combine these? No, they are not like terms, guys. Whenever we are multiplying exponents and variables, you can multiply anything. Adding and subtracting is when we have to worry about like terms. So now that we're to this point, we've got 2x squared plus 4x. We cannot add these together because they don't have the same variable to the same power. They both have x, but the first term is x squared. The second one is just x. So this is as far as we can go. Okay? And if anybody's feeling a little iffy about that, we can run through some more examples like that and make sure that we feel good. Before we try the next one, do we have any questions at all? I'm going to write out the work that we did here. 2x times 2 is what we did. You see that? I just kind of broke it down. 2x times x, 2x times 2, right down here. Okay. We feeling all right? Good. Good. Okay, you guys want to try that last one?
Yeah.
Okay, let's do it together, and then I might give you some to try by yourself. Let's see. Okay, what's my first step here? 4x times x. We're going to have to distribute here since there's a minus separating x minus 5. Okay? So what is 4x times x?
4x to the second power.
Yes, 4x to the second power, or 4x squared. Okay, now I'm going to bring my minus sign over, just like I did the plus. And what do I do next? Yes, 4x times 5. Now, the only reason I'm not saying negative 5 is because I went ahead and brought that minus over. Okay, so that's the only reason I didn't say that. You're really doing 4x times negative 5, and then that negative comes in over here as a minus sign. Okay, so what is 4x times 5?
20x.
Yeah, 20x. So it is 4x squared, or 4x to the second power, minus 20x. Can we combine those? No, they're not like terms. Good, good. So we're going to circle that. That is our answer. Okay, guys, that is wonderful. You guys are doing so good. Absolutely wonderful. Okay, does anybody still need to write any of this? Or are we still looking up here? Okay. I would like to give you a couple problems to try by yourself, and then we'll check them. Let's get a piece of paper. Get a new one. Okay. So, I'm going to write on top of here, practice problems. Zoom that in a little so we can read the problems. Okay, for the first one, let me find a black pen. I want you to do there's number 1. And I'm giving you guys some tricky stuff here. But I know you can do it. There's number 2. I'm gonna give you 4 problems, and I'll give you a little time to do them. I'll set a timer. Here's number 3. Okay. Okay, actually, I'm just going to give you 3 because I think those might take a while. Just 3 for now. Don't worry about 4. Okay, I'm going to pause this recording, and I'm going to give you guys, honestly, I'm going to give you like 10 minutes to do them. So what I saw while I was walking around the room is some excellent things. You guys are really, really grasping this, and that is wonderful. So let's talk about number 1 together. Who feels confident? And this time, instead of everybody shouting at once, I would love for you to raise your hand. I'm going to close my eyes, whoever I see first. Walk me through this problem. Yes, ma'am.
3x squared times 5x
Perfect.
plus 2 would get you 15x to the 3rd power.
Okay.
And then the second part of it would be
Plus, thank you.
6x squared.
6x squared. Did anybody get something different than this? Did everybody get this answer? Tasha, tell me, what'd you get?
Not that.
What did you get? I want to hear.
I got,
We'll talk about it.
yes, I got 8x squared. Minus 5, yeah, I said exactly what I did. I did not get that.
Okay, 8x squared minus what?
Yeah, that's what I was waiting for it to come around, but I was like,
I'm sorry,
it's
Tasha.
alright. It says minus 5, yeah.
Just minus 5?
That 3 is in there, you have to.
Yeah.
Okay, so let's walk through this and let's see. So, I can tell by looking at this, it looks like when you took 3x squared and 5x, I bet you did 3 plus 5.
I did, that's exactly what I did.
Yes,
That's
so
exactly what-
remember, whenever we are using distribution, what operation is that?
Multiplication.
Yes, so Tasha, I want you to tell me, what is 3 times 5?
It's 15.
Yes, so we're going to cross off that 8 and we're going to put a 15. Okay, so we got the number part.
Alright, so
Now let's look at the exponent part.
Okay.
We have x to the 2nd power
But then there's
times
just hanging around.
x.
So that's another x, so that's a 3.
Yes.
So it's x2, then it's x1, so that's 3.
X to
So
the
then
third
15 to the 3rd.
Yes, so 15x to the 3rd power, because I have 2 x's here.
Yes.
I have 1 x here. So I need to add those to get x to the 3rd power. So my first part of my answer is 15x to the 3rd power.
Write that down.
Yes, write it down.
I did the exact same thing.
You
I was
did?
like, what?
Anybody else do the same thing?
No, but I forgot to, on the second part.
Uh-huh.
When I times the 3 to the 2, I put 6, I forgot to bring my x to the 2nd power.
You are not the only one. I saw a couple of people do that. And that's okay. You know what? I love whenever when you guys feel comfortable enough to tell me the mistakes that you're making. It builds community with us because so many other people will make the same mistake and you'll see you are not alone. Like, it is so common. And when I can see those mistakes, I can address them and we can fix them together. Like, we got this.
Yeah, but then I went over to the second one and did that one right.
Oh, well, that's good. That's good. That's okay. We got this, guys.
Yes.
Okay, so we got the first part. Now, Tasha, tell me about how you got net minus 5.
Because, so let me look down here and do my work. Here's to minus 5. I did, the 3 and the 5, and then I did the x2, and then I did the 1. No. I don't know what I did. I was going in my brain. I didn't do it right.
Do you think you accidentally mixed it up with the next problem or
So
something?
what I'm looking at, it looks like,
Because I'm not sure where that negative.
I'm not sure where it came from either, honestly.
Okay,
Yeah, I'm just not sure.
that's all right. Well, let's walk through how to do the proper part. We're going to just
All right.
get rid of that.
Plus 6x, 6x.
Yeah, so now we have 3x to the second power, and we're taking that times 2. What's going to happen there?
2 times
3 times 2 is 6.
6.
Yeah, so we got 6.
3 times.
There's no x, so it's just 2. Bring 2 over.
So here, let's go real slow.
15.
First, Tasha, what is 3 times 2? 6. So we're going to write a 6. And now we have x squared on our 3. And is there another x to multiply by?
No. So you just
No. So do you know what happens there if we don't have another x?
just carry on.
You just bring it back over. You don't have to change that exponent. It's just going to stay x squared. Just like that. Okay? Does that make sense?
All right.
All right. So we're going to write it down.
All right.
Get it in our brains. Okay. Yes, Mac, were you going to say something?
Go first for the next one.
Okay, you ready? You want to tell me the next one?
Yes.
Okay, tell me. Number 2.
The answer to number 2 is 4x to the third power minus 8x.
Did I write? Hang on, say that again. What was the first part?
4x to the third power.
Okay, 4. Hang on.
The answer is 2x to the third power.
And I looked at your paper.
You did.
I did. If this was a 2 right here, that would be correct. Did you write 2x squared in your on your paper when you copied it down, maybe? Because now that I'm looking at my paper, it looks different. I'm sorry. So, Mac, on your...
I thought you had me over here.
No, you got it, girl. It's my fault. So, on your paper, what's your original problem say? Can you tell me that part?
Now she confused me. Now I just gotta go through it and do it again.
No, it's okay. So, can you tell me what was your original problem that you wrote down?
2x times 2x.
Did you write a 2 in front of your x squared?
No.
Okay.
That's probably it.
Okay, so let's get rid of that.
I didn't write the problem down right.
Okay, so that's what happened. So, what you wrote down, you did do it correctly. You got it right. But...
That's what I got too. I didn't write the problem down right.
that's okay. That is totally okay. So I'm sorry. I didn't want to give you that false whatever. You're doing it correctly. It's just a different problem that we're looking at. So what if, since I know you know how to do it, do you want to walk me through what I've got up here on the board instead?
You do 2x times 2 to the second power.
So let's pretend there's no 2 here. I didn't have a 2 here. So just 2x times x to the second power. What's happening here?
That would be 2x to the third power.
Yes, perfect. Thank you. 2x to the third power. And then what?
You do 2x times, bring down the negative, it's going to be a negative 4, but bring down the minus sign.
Uh-huh.
You just do 2x times 4, which would be 8x.
Yes, perfect. Okay, you got it. That is
Can't
excellent.
go any further, so that's your answer.
Yes. Thank you. So, I forgot to circle that first answer. Number 2.
I keep adding because I.
That's okay.
6x.
Yeah, number 2, we should be getting 2x to the third power minus 8x. Because whenever we do 2x times x to the second power, we're not multiplying our 2 by any other whole number here. That 2 stays the same. Now we have x times x to the second power. X to the second power, remember, and if this helps, maybe do this, guys. Above each of your x's, I've got 1x here. I've got 2 x's here. Now I know 1, 2, 3, there needs to be a 3 above my answer, okay? See how there's 3 of them? And then I've got 2x times 4, or negative 4. That's going to give me 2 times 4, 8, x times nothing, or I guess an invisible 1 or something. It's going to stay there. It's going to just be an x. We're not going to change the exponent at all. Does that make sense, you guys? Okay,
Just
awesome.
going to assume it's hanging around.
Yeah, it's just hanging around. It's just hanging around.
Yeah.
That's right. Okay, questions about number 2? Any questions? Okay, can we try 3?
Yes, please.
You got your hand up?
6x to the 6th power minus 15x to the 5th power.
Yes. Okay, guys, is everybody getting this answer? 6x to the 6th power minus 15x to the 5th power. Yes or no? Okay, raise your hand loud and proud if you didn't get it right. Okay, if you got it wrong, tell me. Who got it wrong? It's okay if you did. We can
First
go.
time, but then I had to go back and redo it, so.
Okay.
A whole bunch of different squiggly wigglies on there.
All right. You want to go through it step by step?
Yeah, we can do that.
Let's do it. Let's do it real quick. Let's make sure we all feel good. So, first step here. I've got 3x to the 4th times 2x to the 2nd power. I'm not saying power, but it's powers, guys. So, what's happening with my 3 and my 2? Yes, I'm multiplying. 3 times 2 is 6. And now I've got x to the 4th times x to the 2nd, and that gives me x to the 6th. Because 4 plus 2 is 6. If I'm multiplying x 4 times over here, and then I'm multiplying x 2 times over here, I'm multiplying x a grand total of 6 times. That's why I'm writing 6. Okay. Then we got to do the second term, which is minus 5x. Okay. So we start with our numbers. What's 3 times negative 5? Negative 15. Very good. And now we'll look at our x's. We got 4 here. We got how many here? 1. What's 4 plus 1? 5. 5x, or x to the 5th power. You see how we got that? Awesome. Awesome, guys. Y'all, that's amazing. You guys are doing so good, really. You should be very proud of yourself. This is not easy stuff. Tough stuff, and you're doing it very well. Okay. Let's see what I wanted to finish off with. We've got a migraine. I heard that. Okay, we got about, 12 minutes. I would like to go ahead and give you guys an exit ticket, okay? Your first accuracy grade in the class. Every time that you do an exit ticket, please label it by writing what we go by days in this class. Today is day 2. So I'm going to write up here what I want you to write. Day 2 exit ticket. If you want a loose piece of paper, there is plenty up here by my desk. You're welcome to grab yourself some. Oh, you're okay. So day 2 exit ticket. Please also write your name on it. Write your name so that I can give you a grade. And also remember, with exit tickets, you do have until 1 week after I assign it to officially turn it in. I would always recommend turning it in much earlier than that, because if you make a mistake and I grade it, give it back to you, you see that mistake, you then have the rest of the week to correct the mistake and improve your grade. Okay, so I'm trying to give you enough time so that you can finish this before you leave today. Okay, because we still got 10 minutes, and exit tickets, I like to keep them short and sweet. I'm going to give you 2 problems. So number 1 going to be 4x times some bigger numbers here, slightly. And number 2. And when you're done, guys, you can turn it into that middle bin up here at the front. It says Algebra 2, period 2, 3. And you are free to go once you finish. So, let's see. Let's do... Okay, so I want you to simplify these expressions. And I'm going to end the recording there. That's all, guys.